Let's solve this problem together. We have a cube minus a squared to be equal to 100. So let's begin by moving our 100 over to the left hand side. To have minus 100 is equal to 0. From here we have a to the power of 3 minus a squared minus our 100 is the same as 125 minus 25, and this is equal to 0. So we have a to the power of 3 minus a squared minus our 125 is the same as 5 to the power of 3. Our 25 is the same as 5 to the power of 2, and this is equal to 0. So let's open up the bracket to have a cubed minus a squared. Opening this bracket to multiply by minus sign to have minus 5 to the power of 3. So this times this will have positive 5 to the power of 2, and is equal to 0. So let's group the cubes together. A to the power of 3 minus 5 to the power of 3 minus a to the power of 2 plus 5 to the power of 2, and is equal to 0. So we have a cube minus 5 cube minus a squared minus 5 squared is equal to 0. So let's remember our cubic expansion. When we have x to the power of 3 minus y to the power of 3, this is equal to x minus y times x squared plus xy plus y squared. And when we have x squared minus y squared, this is the same as x minus y times x plus y. So we'll be expanding this to have, we have x minus y, which is a minus 5, times we have x squared, which is a squared plus 5a plus 5 squared, minus we have the expansion for difference of 2 squared to be a minus 5 times a plus 5, and this is all equal to 0. So we have a common factor here. We'll factor a minus 5 out to have this, which is a squared plus 5a plus 5 squared, minus we have a plus 5, all equal to 0. So we have a minus 5, we have a squared plus 5a, we have 25. Opening this bracket, we have minus a minus 5, and it's all equal to 0. So we have that a minus 5, we have a squared, 5 minus 4, we have plus 4a, 25 minus 5, we have plus 20, and this is equal to 0. So this simply means that our a minus 5 is equal to 0, and a squared plus 4a plus 20 is equal to 0. So we've gotten from here, we have that a is equal to 5. So let's name this a1, which is the first value of a that we've gotten. So resolving from here, let's name our a to be 1, our b is 4, and our c is 20. Let's record the quadratic formula, where we have minus b plus or minus square root of b squared minus 4 times a times c, 2a. So our a is equal to, we have 4 plus or minus 4 to the power of 2 minus 4 times 1 times 20, all over 2 times 1. So a is equal to minus 4 plus or minus, we have 4 to the power of 2, which is 16. We have 4 times 20, which is 18, all over 2. So our a is equal to, we have minus 4 plus or minus This minus this, we have negative 64 all over 2. So a is equal to minus 4 plus or minus the square root of 64 times the square root of minus 1 all over 2. So our a is equal to minus 4 plus or minus root 64, we have 8, and root minus 1 is I over 2. So from here we'll factor out 2 to have minus 2. Factoring out, we have 2 plus or minus 4i all over 2. So a is equal to, we have minus 2 plus or minus 4i. So we have a complex root here. That means our a2 is equal to minus 2 plus 4i, and our a3 is equal to minus 2 minus 4i. Thank you for watching to the end of this video. Subscribe and hit the notification bell so you don't miss out on any of our solutions.